In this video, we will understand the implementation of bottle filling plant logic using DCS and implement the same on Virtual Lab Simulator. This is the bottle filling plant process diagram. We will understand the diagram in detail, and this is the logical circuit diagram to implement the logic. Now here I have drawn the logic circuit diagram as well as the process diagram side by side so that we could understand both the logic circuit and what is actually happening in terms of process simultaneously. Now as the process starts, command is required from the field operator as well as from the control room through DCS. And at the start of the process, each bottle is kept manually on the conveyor belt. Now before we see the process in detail, there are few sensors and other things that I want to discuss about, and we will see how the process happens after that. First is the limit switch. Now as the process starts, each bottle moves from this position on left to this position right under the solenoid valve, and when the bottle reaches this position, this is sensed by a limit switch. Now when limit switch senses this, two things happen. First, the conveyor motor stops, and the other thing is that there is a pneumatic cylinder which raises the bottle platform before it starts to be filled from the solenoid valve. So this is the limit switch, and this is the conveyor motor and the pneumatic cylinder used to raise the bottle platform in the logic circuit. So now let us understand the logic circuit in detail. Initially, when the process starts, input from all the sensors would be 0. So the input from limit switch would be 0, as well as the input from proximity coarse and proximity fine sensors would also be 0. Also initially, this timer would be in reset state. The bottle platform, it requires 5 seconds to raise its level by pneumatic cylinder. That's why this timer of 5 seconds is placed in the logic circuit. It represents the 5-second time lapse which is required for the bottle platform to be raised by this pneumatic cylinder before the bottle could start to fill. So now to start the process, input from the field operator as well as from control room through DCS would be 1. Due to this, these two inputs for the AND gate would also be 1. Since the limit switch input is 0, hence due to this NOT gate, this input would be 1 and this input would also be 1, and this AND gate would be logically on. This input for the OR gate would be 1, and since the proximity fine sensor input is also 0, so this input would be 0, but since this is an OR gate, so this input is enough to turn it on. Output of the OR gate would be 1 and the conveyor motor would start running. Subsequently, the pneumatic cylinder is in off state. From the logic circuit, we can easily see that when conveyor motor is running, pneumatic cylinder would be off, and when pneumatic cylinder is in operation, the conveyor motor stops. It can be seen from the process diagram as well that when conveyor motor is running, the bottle moves from one position to another, and when bottle is right under the solenoid valve as detected by the limit switch, the conveyor motor would stop, and this pneumatic cylinder which is placed here would raise the bottle platform before the bottle could be filled by the solenoid valve. So now when conveyor motor is running, this bottle is placed on the which is placed on the platform. It moves from this position on left to the position right under the solenoid valve. And when bottle reaches this position, it is sensed by this limit switch BP. Now when limit switch BP senses this, the input from limit switch would be 1. Due to this NOT gate, this input would be 0, and gate becomes logically off. The other input of this OR gate would also become 0. OR gate is also off. The conveyor motor stops, and due to this NOT gate, the pneumatic cylinder is in operation. Hence, when the limit switch detects that the bottle is right under the solenoid valve, the conveyor motor stops and the bottle platform is raised through the operation of pneumatic cylinder. Something like this. Now, as I told earlier, to raise the bottle platform, 5 seconds are used. So, moving further, for this AND gate, due to this limit switch, this input would be 1, and due to this NOT gate, the other input would also be 1. This AND gate becomes logically on, and the timer of 5 seconds is initiated. Now when the 5-second time has elapsed, this one would reach at the output of the timer. Now the timer would output 1, and this solenoid course valve would start filling the bottle. So this is the solenoid course valve. This would start filling the bottle. After the bottle is 90% filled, it is sensed by the proximity course sensor. Hence the input from this sensor would be 1. Due to this NOT gate, this input of AND gate would be 0. This AND gate would be off. This will cause the timer to reset and the solenoid force valve will now stop. At the same time, this input from the limit switch would be 1. This input from the proximity core sensor would also be 1. And due to this NOT gate, this input from the proximity fine sensor would also be 1. This will cause the AND gate to become logically on, and now the solenoid fine valve would start filling the bottle. So this is the solenoid fine valve. This now starts filling the bottle. Now when the bottle is 100% full, it is sensed by the proximity fine sensor. So now this input from proximity fine sensor would be 1. Due to this NOT gate, this input would be 0. Due to this AND gate would be off, and the solenoid fine valve would also stop. Hence, the bottle is now 100% full and the solenoid valve stops filling the bottle. Now, with this, the counter is incremented by 1, and also this input now becomes this input now becomes 1. Now the OR gate once again turns on, conveyor motor starts running again, and due to this NOT gate, the